Hello, I think I'm live. Hello, my name is Carlos. Welcome back. This is part 7 of the series that I started recently called Let's Make Zelda for NES, this time on 3D, right? On June 1st of 2025, I gave myself the task to start working on this. After finishing my previous game, I put it out there and now it's time to start a new project. This is my favorite game of all times. And so this month, on my spare times, on my weekends, and whenever I can put some time to it, I've been working on it, and I'm happy to report that I've been able to, as you can see here, let me make it a bit bigger. The world itself, the outside world, the overworld is complete. It's done. So as you can see, there's the lakes. There's level 4. There's level 3. There's the fairy fountains, the lost woods, the graveyard. There's level 6 there. There's the Death Mountain. There's the armoses all around the place. There's the final level, level 9. Level 1 is all the way over here, crossing the bridge. And you have, level 2, level 5, the the waterfall where you get your sword, the white sword, so on and so forth. So yeah, this took a while, and it was fun. It was fun. I'm not gonna lie. I love this map. I know it well, and I feel like I know it a lot better now. I know exactly how many green bushes are there, how many brown bushes are there, how many green snail rocks are there, and everything else. Right. So, but now that that's working, the next step for me was let's start making the enemies. And I went around on the internet, look for the pixel art, the actual sprites that was used in the game. And the good news for me is that this game has very basic animations, especially the enemies. The enemies have 2 frames, max 3 frames of animation. So essentially, they're just doing something like that the whole time. They stop, shoot, keep moving around. They all have slightly different patterns. So essentially, what I did is kind of recreate all those models in 3D. As you can see here, I have the Moblins, I have the Tektites, I have the Lionels, Octoroks, P-Heads, Zora, Genie, and Link, of course, is there. So they're all there, right? So that's what I was doing on the last few days. And I'm gonna show you here not only that, right? Like there's a lot of thing else, many other things that you have to work on. For example, this is the rock that the Octoroks shoot. And I have some of the arrows. This is just the regular arrow, but I need to work on the silver arrow. There's, for example, the sword beam. So the Link sword, when it's shot by himself or by the Lionels, the shot has a transition effect, right? Like so, it swaps through all these palettes, so it looks really cool. So it's I'm working on it, right? This will be put together in the future, and it'll look better. This is the energy ball that Zora shoots, or maybe the enemies inside the dungeons, right? So this is the energy ball that it transitions across these models, and I guess once it's animated, it's gonna look a lot better. And yeah, so this is where Magika Voxel, where I was working on that. So essentially, I work on Magika Voxel for a while now. I think it's time to give more life to these guys, right? So I created the frames, the animation frames for each of these monsters. And now I actually all of them. I wired them. I added a script that kind of like cycles through their meshes. And if I hit play, you'll see them in all their glory. Okay, so it's a bit hard to see in that window, but let's try this. Okay, so let's have a closer look. As you can see, the Moblin and the Lionel have actually 3 frames. It's left foot front, standing still, right foot front, and so on and so forth. The same for Lionels. So those are the guys that had a little bit more animation to it. But for example, the Tektites are really simple. They just go up and down, and they're going to be jumping around the place. Armoses too, they also had 3 frames of animation. I don't know why, I really like how the Armoses can turn up. And they're huge. I'm kind of like debating the size that I'm gonna give them compared to Link, Because in the game, they all occupy about the same space. But I think in this 3D version, like I'm fine with the armors as being kind of like, towering over Link and maybe the Moblins as well. And then they have the levers. These two guys right here, Zora and Genie, they don't really have animation frames. I'm looking at the game, going back and forth. These guys just kind of like the Genie, the ghost, just kind of like waddles around, like back, forth, front, back. And Zora just kind of like pops out of the water, faces Link, shoots, and then go back under. So these guys, I think I don't need to make animations. I just need to give that behavior later with code. And Octoroks, of course, look at that. I think their mouth a little bit too long, but when I saw it in the game, it actually looks like that. So, but as it is right now, they're just standing still, not doing much. I can move Link, or I could move Link. I think let me see, there, move around. But right now, there's no behaviors, there's no attack, there's no colliders, no rigid bodies, no nothing. I can attack with my trusty sword, but nothing's gonna happen to anybody. So yeah, I need to start adding the behavior, so the intelligence, giving some patterns to these enemies. And I was looking at, for example, videos like these of the Octoroks, right? Like I'm gonna start from the beginning. The Octoroks are probably if not the simplest, one of the simplest enemies. As you can see, the Octoroks move forward. They sometimes stop, shoot, and they sometimes kind of like just turn 90 degrees on either direction. So essentially move, 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 and then randomly turn, move, 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 randomly turn, or shoot, or kind of like turn backwards like 180 degrees. So it's, I think that's pretty much it. That's kind of their behavior. So once again, let's just look at this guy. It's moving forward, turn, turn. If he hits a tree or a wall, it just turns. If it doesn't, forward, 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 randomly swap 180 degrees, stop, shoot. It seems like it always kind of like before shooting. I just noticed now that I'm looking more closely, even though I played this game for all my life, they never kind of shoot while they're moving. So they're always kind of like moving, 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 stop. And that's when they just give a moment and then shoot. And maybe that gives the player a moment to know that, oh, that guy's going to shoot me, so be careful, kind of thing. So I just noticed that when I was like looking at it this morning. And that's the behavior, the very simple behavior that I'm going to be giving to them. Okay? So I have the prefabs, I have the rock already as a prefab as well in here. So today I'm gonna start working on the code of one called the artificial intelligence of this Octorok. So let's do this. Let's see, AI Octorok. Okay. So let's see. I like to start by doing a recap of what we were just saying, right? So Octoroks can move forward for a while. They can turn 90 degrees or minus 90 degrees or 180 degrees. Okay, I think that they can do 0 or 90 or minus 90, so left or right or backwards, right? So there's like a chance of them, like at every moment they decide, okay, I'm gonna go forward, and then make another decision again. Okay, now okay, keep going forward. Okay, now I'm gonna turn. Now I'm gonna go forward. Okay, turn. So it seems like there's a timer, a random timer between these many seconds, like between 1 and like 4 seconds. The Octorok is gonna make a decision, right? Every 1 to 4 seconds, more or less, right? This is for what I can see the behavior of the Octorok is. They make a decision, as to what's their next action is going to be. If it is to keep moving forward, or if it is to, change directions, or if it is to stop and shoot, etc. Right? And I guess at some point I need to also make them aware of their surroundings, right? If they are going to hit a wall or if they hit a bush, don't just keep going forward, like, just react, like maybe turn or mandate a turn. Don't just stay like, staring at the wall or shooting at the wall, something like that. Okay, they can also shoot. I would say stop, wait a bit, oh, and then shoot. And if hit a wall or bush or link, no, I guess if they hit link, they just keep going, right? They just link just gets pushed back. Bush, then turn. Okay. All right. That's pretty much it. So that's a good thing. That's a good news about this game. Like the AI is basic. I like it. I like it because we can do a lot more progress. So, like I said, seems like they have a randomized timer, right? Like every 2 to 4 seconds, they're gonna make a decision. So that tells me, and I'm gonna expose all these variables to the editor so I can tweak them. So public float, what, like minimum turning interval, and that's gonna be, say, 2 seconds, right? And then the max turn interval is gonna be, say, 4. And this is, we can change this later too, right? No problem. Okay, in the beginning, uh, so I'm just gonna start moving forward, right? And to start moving forward, I can do transform dot translate as forward, vector 3 forward, and then I need a move speed. I don't know, public move float move speed of like what, I don't know, like 3, 4, I don't know, 3. Let's say this is something that we can tweak later. 3f move speed forward times move speed times time delta time, something like that, right? I think with this is enough for now. Enough for now to start moving forward. Let's start just seeing if that actually, to connect this. Just start from there. Now this is a little bit crowded. There's too many enemies here. But anyway, so the first thing I need to do is to find the Octorock prefab. Right. This is for all ones, so let's remove that. And I'm gonna AI Octorock. And you can see I have the variables here that I exposed. So in here later I can tweak them and then get an idea of what works and change it or keep them and everything. Okay, so my Octorock now that has a pattern. And I'm gonna use some other area to test because there's too much stuff going on there. Maybe here, the desert. There's nothing happening here. So I'm gonna throw an Octorock red right there. And let's see if we move forward. Okay. Okay, moving forward it is. Good. And of course it's gonna go through walls. It's gonna be unstoppable, this Octorock. It's just not gonna care. It's gonna go off the edge of the world and probably fall. If I put an Octorock here, let's see if it just goes off the edge of the world. Bye bye. Yeah. Okay, cool. So mission 1, the Octorock moves. But that's not enough. Not even by a little, the long shot. Okay. So now I want it to turn sometimes, to stop sometimes and shoot. So there's like the timing thing that I was talking about, right? Let's see. In the update, right? if it's moving, I want this to be always happening. I want always to be thinking on the next situation. So it has to be, I imagine, here in the date cycle for something to happen. Or I can use an enumerator. Let's call routine. Okay, for example, let me try. I like coroutine. So private enumerator. Let's see, turn cycle, for example, right? And then because I want it to be always active while true, so always enter to this loop. Let's see. Uh, I need to first wait and then make the decision, right? Imagining that it's going to start by walking and then wait the random interval here that I had set, right? So between 2 and 4 seconds, take the next decision. So new and then wait for seconds, random range, and the random range is going to be mean turn interval and max turn interval. Once again, we can tweak those. Right, so what's doing it here is, let me close this thing, the camera, player animator, that doesn't need to be there. So you can see a bit better. So what's doing here is that you're always gonna enter this while because it's a truthy statement, and then wait for a random amount of time between 2 and 4 seconds, and then when that happens, because it's a turn cycle, let's see. Like, what would be the probability of this Octorok to turn? Would you say like 50%? Let me see. For example, another here. Public float turn probability is equal 50%, right? So if the turn probability, so if another random range, if random value minor is turn probability. So if it's like 50-50, right? Then he's gonna turn. He's gonna turn, and again, like I said, like it could turn 0 degrees, no, minus 90, 90, 180, right? So we have like three possible choices there. And it's always gonna be the same, one of these three values. Because I mean, it's a 3D world. So in a 3D world, it could go. I mean, I suppose it could go in 45 degrees, any kind of degrees. But let's start from the basics, right? Like the behavior in the original game. So in here, I can pick like minus 90 degrees or 90 degrees or 180 degrees. And I'm gonna put them in an array of angles, and I'm gonna store them, like hard code them. So just one of them is like that, and the other one will be 90 float, the other one will be 180 float. Close it, and then choose one of those, right? And then if it goes into this if statement, it's gonna transform and rotate this entity, which is gonna be the Octorok. So in X, no, on Y, it's in Y, right? Because it's rotating like that. So if I look at this Octorok, I want it to turn. So this is the Z-axis, X-axis, and Y-axis. And I want him to turn on this green one, like this. And that's the Y-axis. So I need to turn him on the Y-axis. So that means X is 0. And then this one is the one I wanna choose, right? Angles, it could be, choose one of those random angles. Random range between 0 and angles length. I'll explain what I'm doing here in case you're interested. 0 in Z. Okay, So this array stores these three values, right? Imagine it's a drawer with three boxes, and in each box is one of these values. The top box has minus 90, the middle one has 90, the lower one has 80. When I want to rotate something, in this case, because this script is attached to the Octorop, you're modifying the transform rotate. And what is a transform rotate? It's exactly this circular thing that I get when I click on this entity. It can have a rotation here with this value, and you can see the rotation here in Y, in X, and Z. So I'm accessing those values and by how much you want to rotate. And then in here, normally, you can see here in the description, it says void, transform, rotate, float, X angle, float, Y angle, float, Z angle. So it means that how much you want to rotate in each axis, how much you want to rotate in X, how much you want to rotate in Y, how much you want to rotate in Z. But in our case, we don't want to rotate it in anything but the Y axis. So that's why the first one is a 0. X is a 0, so do not move the X axis, do not rotate in that angle, and do not rotate either in the Z axis. What I'm doing is I am, here, this is X, this is Z, and then this is the whole Y angle. This is the whole Y angle. What is it doing? I'm just telling from my drawers of array, my drawer of angles here, my array, you're gonna randomly choose a drawer that is one of these three between index 0 to the length of this array. Arrays are count from 0, 0, 1, 2. For example, the length of this array is 0, 1, 2, is 2, even though it's 3 elements. Computers like to count from 0. So essentially, you're telling him the Y angle that you're going to rotate is randomly chosen from here, one of these three. Okay? And that's it. So, for example, if I just do this, let's see if it start rotating every now and then. The way I'm making it right now, it's gonna for the most part go straight. It's gonna turn less often than going straight. Ah, let me check here. Yep, it's going straight. Yep, totally going straight. Maybe it's a little bit too much. It's not turning at all. Did I not save the script? Okay, so this guy is not turning. Definitely not turning. Turn probability 50%. Okay, so something didn't work here. I know what's going on. So yeah, this turn cycle is never called. It's never called. As you can see in my editor, is like deactivated because it's just never called. It's not in the update method. It's not in the start method. So I need to put it somewhere. And because I want this to happen from the get-go, I can actually call this from the start. So the start method is a base method that is going to run once when this entity comes alive. So when the Octorok spawns for the first time, whatever you put in the start method is going to run once. And whatever you put in the update method is going to run on every frame. So it's costly, but it's not much. So in here, and because this is an enumerator, so it's a subroutine, it's not a method itself. I have to call it as a start coroutine. Coroutine, and then what did you say it was? Turn cycle. Turn cycle. But I have to call as a method, right? Okay, now you can see it activated here. So now it's part of the. And every time I update my code, Unity has to compile again, but doesn't take very long. Alright, let's see. Let me put this guy a little bit further back. Oh, let's put a few. Octoroks. One here, one here. Let's see what they do. And let me go back to the scene here. Oh, that one turned. Oh, that one turned. But, they don't have colliders. They're going to go through the walls. Yeah, that's to be expected. Yeah, but this guy turned. Yeah. Yeah. Okay. Okay, they might be going a little bit too much in straight line, but I think that's what we saw in the video just now. Let me show you. So I'm not crazy, right? I'm not making this thing up. It's where is the YouTube video that I was showing you. I think I closed it. I closed it. I have a video of the Octoroks. Like, let's look it up again quickly. Let's see. Because if I'm YouTube, let's see. Watching YouTube while streaming in YouTube. So Octo. Oh my god, how do you Octorok Zelda NES? So which one is a good one? Evolution of the Octorok. Yeah, that's the one. Check it out. So go straight, 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 straight. So go. Oh, this guy's going all the way across the screen. So that's what I mean. Like I've seen them going quite a bit long distance straight, right? So that was that. Okay, let's just focus on one. So this guy goes here, bumps into the tree and turns. Shot. Every time bumps into the tree, immediately turns. Makes sense. So now it's kind of trapped here. Okay, went the other direction, turn back, shoot, straight, 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 straight. It seems like he was gonna turn there. Okay, it's a little bit more dynamic, a little bit more dynamic, but it's okay. It's okay. Look, what I like to do is first keep the behavior and then tweak the variables. So all is gonna be here. For example, if I increase the probability of them turning to 80%, they're gonna turn quicker or more often. So let's try again. Put it here. Yeah, so I don't think this guy's gonna make it all the way down. There, he turned. So because they go into that if statement in the if turn cycle 80% of the time, not 50. Still, I feel like maybe it takes too long for them to make a new decision. So maybe my interval here, like for example, if I put 3, 1.5, so between 1.5 and 3 seconds, it's gonna make a new decision instead of between 2 and 4. That's it. Ah, make a new decision. 1, 2, 3. Mm. And once I deal with the walls and everything, they would be contained into one. So it just kind of like went off. And I guess if you put more, it would be more interesting to just kind of spawn them all. Yay. Right, so every time I drag and drop one of these guys, so the first thing they do is to start the start method. And then on every frame, they're running the update method. Look at them. So cute. So cute. It's like adding them like this is gonna bring life to the game. Right, but they're the baddies, right? So they're gonna be shooting crap at Link. Not crap, the rocks that I already made. I don't know. I hope they're rocks because they're not called Octocrap. They're called Octorocks. So I'm gonna do kind of the same thing. Kind of the same thing. Another private, and this one's gonna be what? Like the shoot cycle to have a similar name convention than the other one. Uh, Again, while true. So always be doing this, which is first, once again, wait for time. Wait for the time to make the next decision. Oh my gosh, hot today. Let me turn on the aircon. Oof. There. Look at my glass. Like, so you don't say that I'm not a fan. Like, hmm Same deal. Maximum interval. Hang on. Mm, mm, Time. Should I make a different timing for? How often do they shoot? Let me have a look again. How often do they shoot? They shoot more often than they turn, or less often than they turn. See what I mean? Like they're turning every 1 to 3 seconds, but I don't think they're shooting that often. One. Okay, let's just focus on one of them. See how many times each shot. Okay, let's focus on the guy on the very left. Whichever is gonna be the leftmost, I'm gonna focus. This guy. Not shooting, not shooting, turning, turning. Okay, he got killed, never shot. Let's see. This guy is the guy that lives the longest. How many times he shot? Who was it? This one? One, two. No, got killed. Oh my god. See, I think they shoot a lot less often than they turn. Makes sense. Otherwise, they would spam the shooting. Okay, the next screen. So this one. Moving, 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 turning. Shoot once. Moving, moving, turning, 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 turning. Just shot once the whole time. Two, two times, and get killed. So in like what, like 12, 15 seconds, it shot twice. I mean, I know this is just a tiny sample, but it's all right. It's all right. We're using randomizers and giving us buffers of time, so it's okay. In that case, I don't really want to use this turning interval. I'm gonna use or what I call them shoot probability, and I'm gonna once again making them public. Or if you want to be a little bit more careful, right? This is probably better. So here we not just make them public, make serialized fields. This is better practice, and then you put them private. I'll explain a minute what I'm doing here. Quickly, private, yeah. Just if you're interested, right? Because this could be a teaching moment in case you're serious about learning C sharp. Uh, when you're writing a script, you're normally what the first thing you're going to be doing is declaring the variables that you're going to be using. What's that? Is the information you're going to be working with. You're going to be processing times, speeds, I don't know, probabilities, health, HPs, coins, things like that, right? And there are data types. In this case, I'm using floats. Floats mean are numbers that have not integers. That's integers, int, and floats is non-integers. Like you can have 0.00000 and so on and so forth. In my case, yes, those are integers 2 and 4 and 3, but the idea is that I can, if I want to, later change it to 2.5 to 2.8 if I want to. If I set int, I would not have this flexibility in the future. So if I know an integer is going to be an integer forever, like a value, like for example, your rupees, those are going to be an integer. You'll never have to worry about floats because there's one integer, like 1 rupee is the smallest amount that you can have. So in those cases, yeah, you put an int. But in the other cases where it's times, things like that, you want to keep yourself flexible and you use floats. And public and private. So when I started writing this, I wrote public. And the idea is whatever you put public, it has two main effects here in Unity. One of them is that they get exposed in the I didn't even say serialize octo right here. So everything that I had set as public before, it comes out here. So when the game's playing, I can move those values and tweak those values here without stopping the game, changing the code, running the game again, see if it actually did what I wanted, right? And that's one effect of being public, that it can be accessed from not only within this script, but from outside, the editor or other scripts, other classes. That's a good thing if that's what you want. But what you don't want is to make everything public and then you give access to other classes, to other entities to modify these values that you might not really be wanting to, right? That could lead to bugs, could lead to confusion, and could be hard to debug sometimes when you don't know why some value is being affected by who is calling this and changing my Octorok speed like another class that has nothing to do with it, like somehow you made a mistake or something. So what you do is just put them private. Private is so that they can only be handled here and they can only be used in this script, in this class. Uh, so that's it. But then if you do private only, for example, check it out. If I remove the serialized field word here, this minimum turn interval I saved, minimum turn interval is going to go away as soon as it compiles. Hey. I swear. I swear it's going to. Hang on. Huh? Compiler errors. Ah, yeah, okay, there's an error. So I need to fix that error so it compiles. Oh, I didn't finish creating this. So, seconds, 1, F, and close it. Okay, so there has to be, if there's an error, Unity won't run. Like it will let you know. So it's an exception or some error. Okay, now that it's saved and fixed, see, like the first value is gone because it's private, right? But I don't want other classes to modify it, but I do want to have access from the editor. In that case, you do this, you add this serialize field. So in Unity, this is a very common thing that you see programmers doing. So you serialize your field, you keep it private for good practice, and then you put it like that. So this is better. This is better, right? And it doesn't affect my functionality here whatsoever. It's just in the future, I'm a bit more protected, and I can still tweak it from the editor. So where was I? I was gonna make a shooting probability, a timing for shooting. So I said that they shoot a lot less often than they turn. So, and then once again, serialize field, private, float, minimum, minimum time between shots. I don't know, let's say 8 seconds. And its counterpart, so I'm just going to copy paste this line and modify it. It's the max time between shots, that's say 12. So I can work with that, right? Yeah, let's start with that. So here, so return. So in here, instead of waiting 1 second every time, I have to do the same what I did here. A random range that uses the minimum shoot. No, what did I call it? Minimum time between shots and the maximum time between shots. So random range, the way it works is this expression is going to return a random number between this value and this value. So in between 8 and 12, I'm going to return a value. And because it's between in these green brackets, is the number of seconds that I am going to wait, that this shoot cycle is going to wait every cycle before moving on to the next few lines. So I have that. What? I also noticed that, they don't kind of like shoot, like when they shoot, they stop and they shoot, right? So let me see. Maybe it should, because this is just the probability to jump into that, right? Like every 8 to 12 seconds, it's going to decide to shoot or not. And if it does decide to shoot, then it's going to have to wait for a second. Say, like, it seems like the 1 second, I'm just going to put, right? Let me tell you what I'm doing here. It seems like before they shoot, they wait a little bit. They just immediately shoot when they're moving around. That probably give you link time to react and to prepare. So like, oh, that when you see an Octorok stopping, it's gonna shoot in a moment. So yeah. So in that case, then I'm gonna make another method just to shoot, which I haven't made. So I have to make that. Okay. Let's see. And then I'm some private void shoot. Now, to shoot the rock, so I need to assign the rock here. So serialize field private game object rock ammo, or what should I call it? Rock prefab. That's good. Yeah, so this is another kind of variable, a variable of type not float, not int, but game object, like a whole game object, like the Octorok is a game object. The rock is a game object. Everything in here, this bush is a game object, right? So what I'm gonna be doing here, so I save. Did I save? Save. Come back to Unity, and then here in the script somewhere, once it compiles, there. Go back, October Red, rock prefab. And it says none. So what I need to do is to drag and drop my rock prefab. There. Right? So now I have access to this prefab and I can spawn it. I can instantiate it whenever I want, which is when this method is called shoot. Okay. Shoot. Um, so yeah, I want this thing to spawn where the Octorok is. That kind of sounds stupid, like, oh, duh, but you have to tell that to Unity. Otherwise, it'll spawn it in the center of the world, like somewhere. So what I want is to use the same location as this Octorok, as the spawn position. So, and in Unity, all the positions are given by vector 3. In a three-dimensional world, you have to create a vector 3 to define a position. And the way you do that is you really just say vector 3, and then you give it a name. So it's going to be spawn position. It's going to be transform position. I'll explain what this is going on. Plus, like from the mouth, right? So not within the Octorok, so a little bit forward on the Octorok. So transform forward. That's where the trunk is. Plus 1F. Just one notch of it. Okay, so what's going on here? I want to create a position where the rock is going to be created. And this position is going to be transform position here. If I say transform position here, in this script, it's referring to the Octorok this script is attached to. You don't have to say game object punto transform position. No, you just say transform position, and the script will kind of say, okay, this Octorok is in this position right now, so you know it's going to be here. But say the Octorok is this round entity, and so if I just make the spawn position the same, the rock is going to come from the center of the Octorok, and you know they had this massive mouth, which the rock comes from. So just for like accuracy, you want to, the spawn position, yes, here in the center, but then pushes a little bit to the notch, to the front. One notch, just one notch, so it kind of seems like it's coming out of the mouth. And this is what I'm doing forward. So plus the transform forward, which is like whatever direction the Octorok is facing, that's the forward vector. So add a little bit of space in there, which is just like a one unit. I don't know, maybe I need to tweak this a little bit more. Maybe it's too far, maybe it's too close. Okay, now you have the position you're going to use to spawn the rock. Now you have to spawn the rock. And then we are going to say var rock instantiate. This is how you know how I was dragging and dropping Octoroks onto the game. Yeah, I'm instantiating them, but I'm instantiating them manually. Obviously, you cannot do that in the game always, right? This is just while you're developing, but to instantiate, to appear something, a prefab in the world, you can use this method, the instantiate method. And the instantiate method has a few overloads, a few ways in which you can actually call it. But essentially what you need to tell it is basically three things. What do you want to instantiate? In this case is my rock prefab, which I drag and drop in the editor, and it's called rock prefab. Yep, so please instantiate my rock prefab. Got it. Where do you want to put it? And luckily enough, I have the spawn position, which is the vector here that I created, plus the tiny bit in the mouth. So I can just put it here. And last question, what rotation here? Quaternion rotation. So in this case, I don't need a rotation. Quaternion identity, it means that use the same rotation that the rock has. Like I don't need to rotate the rock in any direction. Like if you need to spawn something in a position in a certain rotation, you can do that here. You would say like spawn it at this position and facing that way, right? Okay, I think that's fine. Mm, let's try that. Okay, now shoot cycle is deactivated because like turn cycle is not called anywhere. So I just need to do the same. I put it in the start method. So that as soon as it starts, just get it started. And I said, yes, start method is just called once. So it's called once before on the first execution. So how come is it you're just gonna shoot once? No, because okay, what you're calling once is this coroutine, this enumerator, right? And this thing is always gonna be running as long as this Octorock exists. It's always gonna be doing this because while true, you're essentially forcing a while loop runs while this condition is true, right? If I say while one equals one, one is always going to equal one. So it's always going to happen. So this is something that you might see. While true means that while one, while yes, like it's just you're forcing it to always run. Yeah. So every 8 to 12 seconds is gonna shoot, right? It's gonna, but before it shoots, it's gonna stop 1 second, I think, and then shoot. Let me see. Let's see what we end up with. Now, this is a little bit too long because we're testing, right? So I'm gonna make it shoot a lot more often. All right, let's see. Hopefully we can see some stones flying there. Let's go back to here. So now we're gonna shoot. Nope. And you guys are not shooting. Why? Let me put more. Is it just like a probability thing? Why nobody's shooting anything? Hmm. No, they're pacifists, these Octorocks. Okay, so I am missing something. They're not even like they're just turning around. It's almost like they're ignoring this. Why? So I'm calling turn cycle, not shoot cycle. Never mind. Never mind. Try again. Take two. Okay. Okay, now I think there should be some shooting action, I hope. Uh, yeah. I see what's going on. Right. So, okay, so you can see here, yeah, they are shooting. Are they stopping? Or are you just shooting? They're not stopping. Okay, I need to fix that. Okay, seems like they're just kind of leaving poo behind them. Okay, couple things. I know what's going on. Yes, okay, so you're instantiating the rock, but the rock doesn't know what to do, right? You need to tell it. Like the rock's like, what? So I'm here. Hey, I'm here where you told me to be. But now what? I'm not giving any behavior to the rock, so I need to do that. Now I could do that from the Octorock, but what I like to do is to create a projectile behavior, a projectile script. And that projectile, we can add it to the rock, to the arrows, to the beams, to the ball from the Zoras and everything. So let's just maybe do that. So the script, create. Uh, yeah, this is projectile. This is the same thing that I did in my previous game in the Treasure of Tarmin. So all my weapons have this one projectile script that they all benefit from, and it gives them, direction, speed, and extra behavior as to, when you hit the enemy, do something, trigger something, right? Like a health decrease or something. Then now we have the projectile. All right, so to make something move, we need, again, our variables. And one of them could be, should I say serialize field private float a speed, right? A speed, and I don't know, let's say 5f. We can modify this later. Uh, and also this stone, if it hits Link, or if it hits a wall, or if it whatever, it'll disappear, right? Like it'll do its thing. But for now, before, because Link's not rigged, Link doesn't have a collider, walls are not have a collider. I If you start spawning things like bullets and like game objects and everything, you can overload your game and your memory, and so you might start getting problems. So when you spawn things, also be responsible to destroy them when you don't need them anymore. So for example, these things, I'm gonna give them a time to live for now. And once the game is more further in development, I'll give them a better a better end of their life, right? Float life time, and like, yeah, 5 seconds. I think within 5 seconds they'll be off the screen. I'll keep 10 seconds to make sure they're off the screen. Once they're off the screen, just delete them. Also, there's a thing called rigid body in Unity. I'll put rigid body, whatever, like that. Rigid body, rigid body. So rigid body gives you physics, access to the physics engine in Unity. And in this case, pushing speeds onto things, onto game objects, you benefit from having a rigid body. Okay, and then because this script is going to be added to the rock and to the arrow and to the beam, when when that arrow, when this rock comes to life, when it's instantiated, then what can I do here in the start method? Well, the first thing, first thing that I can do is to use recognize my rigid body, like find it, so I can actually use it. So get component and rigid body, and like this. So now I can actually get access to the properties, the physics of this thing. And then let's see, in the start, because I don't really need to have an update method. I just really need to give it. Really, it's like an object in space, remains in motion as long as it doesn't meet another force, right? So just give it direction, speed, and it should work, right? So for example, rigid velocity, and normally you do linear velocity. So I get it from here, linear velocity, it's equal. So it's gonna go in a straight line. And what you need is direction and force, like the speed. And in this case, transform forward, right? So from the Octorok, when we spawn it, we use instantiate prefab rotation, no, prefab location rotation, right? So it's gonna kind of inherit from that forward times the speed that we have here. So the speed. That's it, I think. And also, yeah, we said we're gonna be responsible, so we're going to destroy this. I don't know, destroy what game object and the lifetime. Yeah, so destroy method destroy game objects, and in this case, there's this overload. This way you can call it too, by adding a number here, a time into it. So after 10 seconds, it will destroy this. I don't need to do anything in update, so I can just remove it so it doesn't pollute. Yeah, let's see. And I need to add this new script to the actual rock prefab. Not the one for Magika Voxel, but for the rock prefab, which is all the way here. So I'm just going to drag and drop. And now we will apply this logic to this rock. And because this rock is linked to this octo rock, when they spawn it, it will spawn with this logic in here. So let's see if that works. I'm expecting to see. Oh, an error. Rigid body, of course. So I was trying to. Okay, so this is the problem. When my AI tried to instantiate this, the rock prefab. It did instantiate it, but the problem is that upon instantiating that, it's trying to find a rigid body component, which I haven't given to. Like, you have to add it here. So rigid body, there you go. Okay, and then you can see rigid body has a bunch of uh, properties there. So I'm gonna leave it like that, the default. So let's try that. Put more. Hope it's not gonna crash anymore. Oh, eh? Ah, did you see? Like, they are shooting, but you know what's going on? I think they're falling under gravity. Yeah, there goes the rocks. Whee! There goes the rocks. Because the rigid body has gravity enabled by default, and we don't want gravity. Do not use gravity. Okay, here we go again. That was funny. So we're shooting it and they just fall. See, let's go back up. Okay, are they gonna shoot now? Straight line. Just shoot, shoot, shoot. There you go. Oh, oh, they're shooting. Was that a coincidence or? Oh my God, they don't shoot very often, do they? Okay, yeah, definitely there's a problem here. As you can see, all the rocks are flying in the Z forward direction, even though the Octorock is not really facing that direction, because I'm just telling it forward. But what rotation did this have? It comes from the Octorock spawning. It shouldn't be quaternion identity, it should be the rotation of the Octorock. So transform rotation. Is that right? Okay, how do I explain it? Do not use like the default rotation. Use the rotation at which the Octorock is facing at the moment. You know, it's a bit can be a little bit tricky. You have transform position and transform rotation, right? Transform position is these things. You move them around, and transform rotation is the circles. You rotate it around. Okay, so when you instantiate something, like we said, we need instantiate what? The rock prefab. Where? At this position, at the position of the Octorock. And at what rotation? And I said the default rotation of the rock itself. And the rock prefab doesn't have a rotation, so you need to just use this always like the z-axis to the front. But now, instead of the quaternion identity, which is a default rotation of the rock, I'm going to be using the transform rotation. And remember, transform, I'm talking about this Octorock, the script attached to. So use a rotation of the Octorock at that time. So, okay, let me see. Let me try again. Let's see. So play this thing, compile, scene, more Octorocks, so we can see if they shoot where they should. They're not trigger happy, my Octorocks. Oh, see, there you go. There you go. Okay, so now they're shooting the right direction. Want to see more shooting? Let's follow this guy. Ah, yeah, okay. Okay, it's a couple things. The stone is way too slow. Way too slow. So move speed, no, that's not. The rock must have a speed, so let's say 10. Okay, a little bit faster. Have a full 20. Is that gonna work? Oh yeah. Oh, that's fast. Yeah, but I like that. Okay, 20. 20 speed is a good. And as you can see, the stones, they're gonna disappear. So let's follow this one. I don't know if you can see it. So they're gonna disappear after 10 seconds. Yeah, gone, gone. See, the destroy method is also working. So that saves memory, right? Later, as soon as they collide with a wall or a bush or something, I'm gonna destroy them instead of just waiting for time. But for now, I'm just ensuring that while testing, that's not gonna be a problem. Awesome. Okay, so now the speed, we said 20 was better. 20 was better, so I need to come to the projectile and modify here now. And then one thing I kind of noticed is that unlike the real game, once again, let's go to the real game. Did I close it again? God, I think I closed it. Let's look it up. In the original game, Octorok and Zelda NES. Octorok. Huh? Which was it? The video I was looking at. Okay, let's see here. Let's play this person. Okay, first screen. Here, let's see the behavior once again. So we're moving. Stop killing them. Stop killing. Okay, see, they stop and they shoot and they keep moving. Well, I mean, it's hard to see with this guy just obliterating them. Where else are Octoroks? Right here. Okay, see, stop, shoot, stop, shoot, stop, shoot, stop, shoot. Move, turn, move, turn, stop, shoot. So the shooting action comes bundled with a waiting time. So let's try to do that. What I have? Okay, shoot. Wait for seconds. Shoot. Like it is waiting for seconds, but it's not stopping. Okay, so how can I interrupt my movement for a second? Okay, I'm gonna make a flag. So a similar data type called boolean. It can be either true or false. That's all. By default, it's gonna be private bool what? Is paused for shoot, right? So it's gonna be moving around, and at some point it's gonna stop, and this flag needs to be turned true, so the game knows that it shouldn't be moving. This is what's moving him forward. So I know. So in here, I'm gonna use that flag. So if uh, then move. In my update method, running every frame, this line was running freely up to now. It means just keep moving forward with this move speed, right? And now what I'm going to be doing is this flag that I put here and I start at false. If this is false, if the place is not stopped for shooting, then keep moving, right? So because it's false by default here, if I don't add any more code, this is going to keep working as it was happening because this is always going to be false. Now I just need to make it true when I stop, when I'm about to shoot. And when I do that is in my shooting method. So shoot cycle, wait for 1 second. Okay, so here it's gonna be true. Stop moving. So change this flag to true. The update method is gonna oh, okay, I'll stop moving now. Wait 1 second, shoot, and then you're okay to move again. Is pause for shoot is equals to false. Let's see. Let's see that in action. Let me add just more Octoroks from the get-go. More and more. I should add this logic to the blue ones. Why not? Let's do that already. So I just add the AI Octorok. So once you have it, it's great because it just works for everybody. I just need to assign the rock prefab. And I mean, I'm exposing all my variables here, so I can even pause it manually here if I want to, but I'm not going to do that. That's it. So I can probably just spawn Octoroks like that. Let's see. And then Scene. Oh, my legion of Octoroks, man. Ah, yay. So, stop, shoot. There it is. There you go. Stop and shoot. Move, move, move. Stop and shoot. Are they too slow? My Octoroks? Like their walk speed is a bit slow, isn't it? You know what? You know what I'm gonna do? Link. Get there. Get to the desert. See if they're still there. I mean, Link is not overly fast in my version here either. Guy, this is work in progress. So I know Link looks clunky. The animation is kind of shit. Oh, there's one here. Ah, they're kind of coming through the walls, man. Oh, there. Die. Well, I cannot kill it because nothing is programmed yet. But yeah, that's not bad. That's not bad, man. Pew. Let me see. Let me go back to the desert here. They're probably gone, all of them, because they can't go through walls, so they're probably gone. Haha, man, that's cool. But I can put more. I can put more Octoroks. So this is the game view, right? And this is the editor view. So just put more. Just spawn the whole Hyrule with freaking Octoroks. Ah! So let's see. Does that mean, man, they keep going away from me because they're not turning when they hit a wall. That was lucky. They're a little bit slow. I think I want to make them faster because it looks big, isn't it? Like the desert here, it looks kind of like very big. There's not gonna be Octoroks here. It's gonna be the levers, but levers have a different behavior. So I'll work on that. I'm actually thinking that the Moblins have a very similar mechanics to the Octoroks. So shall we do the Moblins? I guess this is fine for now. I mean, I might come back later to add, tweak, logic, clean, refactor, but this is not too bad. This is not too bad. Ah, now if I add this same behavior to the Moblins, but the Moblins don't have a rock; they have an arrow. They have an arrow. So I need to finish the. I haven't finished the arrow, but anyway. So for now, just for now, because I think really the AI of the Moblins is pretty much the same. Like, let's go back to that Let's Play game. Did I close it again? Why I keep closing those windows? I don't. Ah, no, no, no. It's over here. This is the Let's Play. Let's see the Moblins. Moblins. Ah, here, here. Let's see how they move. So walk forward, turn. Ah, move forward, turn randomly. Link, stop moving, man. Do they stop and shoot? I think they do. Oh my god, this guy just kind of on a mission. No. Tektites are gonna be fun because guys are jumping, so it's like a three-dimensional kind of motion to it. Let's look at these Octoroks here. Yeah, I mean they're a bit fast, and also this is a lot smaller. I don't know. Either my characters are too small, but man, I made them to the exact replica of the map, so maybe it's just my imagination. I think they're way faster though, way faster. These Octoroks, and one of them was really much faster than the other. Did you notice? Here, check it out. Hang on, let me just go to the previous screen. This one, look at this one, bolting up here. Why? So this one, look, it's like twice the speed of this other guy. Is that a thing, or is it just like a glitch in here, like some ROM hack, or it just gains speed, like right there, go. Phew. I can do that. I can randomly increase our speed, but I just never noticed that. Now, are the blue and the red ones different in any way? I know they take more hits, but I don't think they behave differently. I need to not watch a speedrun. I'm gonna go back. I have my trusty Zelda game right here, ready for some action. to do some investigation just to see how exactly this thing works. Okay, I want to see the moblins though. Moblins. Yeah, yeah, it's a secret for everybody. Octorock. Okay, here's in the forest. Let's see. Okay, too much crap going on. So let's follow this green guy. Let's follow this green guy. And he's dead. Oh my god. Okay, Link, stop killing everything. Okay, let's follow this guy. So he's moving forward, turning. He's dead. Okay, moving forward, turning. Stop, shoot. Same. So turn randomly, shoot, stop, shoot. Yeah, it's just they shoot arrows. It's just the same thing. I can share the AI of the Octoroks with the AI of the Moblins. I'm gonna do that. Have you ever seen a Moblin shoot rocks? Because you're about to. You are totally about to do that. Um, okay, so where am I? Enemies, Moblins. So Moblin green and Moblin orange. I'm gonna put the AI Octorok, and I'm gonna put the rock because I haven't finished the arrow, and I'm gonna do the same for the green ones. Um, green, so AI Octorok, arrow here, and the rock already has everything. Angular momentum is kinematic, blah 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 blah. Yes, now I'm gonna put a few of those. Have you ever seen moblins in the desert? I don't think you have, at least not officially. Not that this is gonna be any official at all, but it's happening. Orange, moblins. Now these guys too are also gonna. I'm just gonna spawn Link here instead of like at the very beginning. There. I'm also thinking that when I spawn them first, I should not just spawn them facing always the same direction. Like, I don't know how I'm gonna approach that. In the original game, as you know, the monsters, they kind of load every time you change a screen. But in my game, I don't think I'm gonna do that. It's gonna be like open world in a way that you're not gonna be kind of like transitioning from screen to screen. You can seamlessly just walk without loading, without anything. But in that case, am I gonna just spawn all enemies of a whole map at the same time, just in case Link happened to be there? Like maybe I need to put like a range around Link, like a big range, so to speak. Like for example, Link's here, right? In this case, Link's here. I make like a big sphere around here, like huge sphere or a circle. No, it has to be a sphere because it's a 3D. There's levels to it, and if any enemies in that sphere can spawn, see what I mean? It will be like saying, like for example, Link is here. Enemies from here, like level two, the armors here, like they can spawn, but definitely not enemies that are in the graveyard. And that way, you can save some memory, some resources. Because I could say, like, you know what, just spawn all enemies from the whole map all at once. I don't care. Look, I had to make testing. It's probably gonna work. Like, it's fine because we have strong machines, and my first game, the game I did before, I did it for mobile. So I always had to be very mindful of the triangles in your objects, like performance, like low poly versions. This is still low poly, way low poly. So that's why I'm a little bit like, yeah, it should work even if I spawn everything at once. So I could try. But if I see some like performance issues, like maybe I need to come up with a better solution and just spawn within a certain range. Okay, without further ado, I want to see what happens with the moblins. Are they gonna work? Whoa! Oh my god, they're there! They're moving. Are they shooting stones? Yes, they are shooting stones. Damn! Damn! Die, die, die! Ah! Shoot! Look. Look at them. Pew! Pew! Should I make them walk in diagonals? I think so, right? Otherwise, Link's always gonna be safe by standing like on a. I mean, in the original game, you were safe standing like just like on a 45-degree angle. Like if I stay here, that could whoa, be problematic. But man, this looks the part. It's starting to look the part. I'll start to. And you know another idea I have? Let me show you one of where is it? I'm just looking for a game I have here. I just saw it. There. It's a PlayStation 3 game. Underrated, under the radar. Like to me it's kinda hard to play right now because it's PlayStation 3, it's a bit hard to plug and upkeep. Like there's not much on PlayStation 3 that I like to play. This game, 3D dot game reloaded. This is a game, yeah, it's like 15 years ago. But as you can see, it's like voxel art. I love voxel art, in case you haven't noticed. So, man, I'm gonna finish Zelda like a tribute, like as it is exactly in the game. But because obviously I won't be able to publish this because Nintendo would have a problem with that. What I'm gonna do after this is done, I'm gonna reskin everything, change the map around, change the enemies around, like appearances and everything, change some mechanics, and try to release it in some way. Yeah. And when you kill an enemy here, haven't done it of course, but when you kill one, I'm gonna make like the exploding voxels, and the voxel just kind of fall to the ground and can bounce and roll away from you. Direct hit right there. So yeah, this is cool, man. I'm enjoying doing this a lot, and this is interesting. Like I've never been a streamer. I've been doing YouTube videos for a long time, in many channels, different channels, but streaming not so much. Especially not teaching. I'm not trying to teach. Like I hope you find this interesting. Like I'd be happy to make like a proper lesson or something if there's interest on it. Like how to make this, explain it better, get more examples. But as you can see, the beautiful thing here is that we were able to reuse, you write it once, reuse it as many times as possible, and add slight customizations. Just make your life easier as a developer. I'm very, very early on still. Like, it looks like I've done a lot because the map's done and the enemies are exist, but their behaviors is the tricky part. Like, attacks, receiving attacks, registering them, adding colliders, like make sure a Link cannot walk through walls, enemies cannot walk on water. Where can you use a raft, triggering the ladder, like that is gonna become intricate as we go along, which I'm looking forward for that. But I'm still very optimistic that at least the overworld is gonna be done, in due date. And so if you're interested, just subscribe, like, please, and stay tuned because I'm gonna keep posting these videos. I'm not developing everything on camera, obviously, because these kind of projects take hundreds of hours. So every weekend or so, or every few days or so, I will kind of like show what I've done up to that point, and we'll do something here together, and then So every time you kind of find a new video, there'll be quite a bit of progress, I hope. So that's yeah. But I gotta get going today. It was great, and let me know what you think. Do they look the part? Am I missing some of their behaviors? What's going on with that Octorok was moving so fast, like twice the speed? Do they need to walk faster? Like, should they move in a 45-degree angle as well, or just 90, 90, 80? I mean, it's a 3D game, so I'm thinking that they should be allowed to move on 45-degree angles. Because Link does. Look, I'm moving on a diagonal. So I should be expected to do that. I just need to make Link more nimble, and my camera too needs to be a little bit more optimized. Like that's everything is work in progress. So if you have feedback, it's welcome, but just know that it's it's a process. Okay, this is Carlos. Thank you for watching. Have a nice day, and I'll see you next time.